This is the video notes for section 5.1, slides 2 through 4. So section 5.1 is on a topic called optimization. So this is where we are taking some sort of a context and we are trying to find the optimum value for whatever the context says. So that could be a minimum value, could be a maximum value. So we will be using a lot of what we learned in Unit 4 to find maximums and minimums. All right, and then also some stuff that we learned in pre-calc. We have to read the context, and then we'll actually have to set up an equation or equations that relate to the context, and then we will have to find the maximum or minimum or whatever is being requested. So let's read question number 1. It says, you wish to build a rectangular aquarium which holds 36 cubic feet of water. You want the length to be twice the width. What dimensions would require the least amount of glass? All right, so a couple assumptions that we're making. All right, this is going to be an aquarium, all right, and so the top is going to be open, all right, and if it's rectangular, all right, that means the base and all of the sides are going to be rectangles. All right, so I'm going to draw a picture of this. All right, so I have kind of the front face of it, and then it is going to have some depth to it. All right, and then to continue our three-dimensional drawing here, all right, something like that, right? So we have this is our rectangular prism, really, with an open top. So you want to remind yourself here that it's an open top. All right, so now let's label a little bit, okay? You know that a rectangular prism has some sort of a length, some sort of a width, and some sort of a height, all right? Now, you know that the volume of a rectangular prism would be very simple, length times width times height, all right? But you are told that the volume will be 36 cubic feet of water. So instead of V, that's not going to be a variable. That is a fixed quantity. We're going to put 36 times equals L times W times H. All right, so that's easy enough. All right, but now you're also told that you want the length to be twice the width. All right, so that means that L is equal to 2W. So instead of 36 equals L times W times H, we're going to say that 36 is equal to, instead of L, 2W times W times H. Or, in other words, you could say 2W squared times H. All right. So now, that is our first equation that we need. All right, but now, what did it ask for? It says what dimensions, so that would mean what's the length, what's the width, what's the height, would require the least amount of glass. So all of the faces are going to be glass. So we have the 4 side faces and then the bottom face, right? So what we're really talking about here is actually surface area. So I'm going to call it SA. All right, so surface area. So what would the surface area be? Well, it would be the area of all the faces added together. So we have the right side here, which would be a W times an H. But we also have the left side, which is another W times H. So we actually have 2 WHs. Plus, now we have the front side here and then the back side here. Well, the front side, its width is L and its height is H. So we actually have 2 L times H's. All right, and then plus we have the bottom, which would be the length times the width. So that would be an L times a W. Okay. Now, of course, we already said that L is 2W, so we could say that surface area is 2WH, right? So I can just write 2WH, all right, plus, but now this would be 2. Now, instead of L, we could write 2W, all right? So this would be 2 times 2W, which would be 4WH, and then plus, instead of LW, I could say 2W times W, or 2W squared. All right, so now that looks great. But the problem is if I want to find where the minimum of surface area occurs, I would need to, get rid of one of these variables, W or H. And so I'm going to come back up to this equation where 36 is equal to 2W squared H. So if I solve that for H, and I have H equals 36 divided by 2W squared, or 18 over W squared, Then I can write surface area as 2W times H, which is 18 over W squared, plus 4W times H, which is 18 over W squared, plus 2W squared. Now I have surface area as a function of only W. So now I could go ahead and find out where the minimum of surface area occurs. So in order to continue, we would want to simplify this. All right, so how do I simplify? All right, so surface area equals, all right, now, in both of these, right, I have a W over W squared. So we can reduce the W's, right? And then I have 2 times 18 and 4 times 18. So obviously I could add those together, right? So if I had 2 plus 4, that would be 6. So 6 times 18, so 6 times 10, 60, plus 6 times 8, 48. So that would be 108 over W, or W to the negative first, and then plus 2W squared. All right, so now I have a really nice looking equation. So now we can take a little trip back to unit 4. Okay, if this is the surface area function, this is the function that we would like to figure out the value of W where surface area is minimum. All right, and so what I want to do is I want to take the derivative. Now, SA prime is going to be what? Well, it would be negative 108 W to the negative second plus 4W. All right. Now, we're going to figure out where the minimum occurs by setting this equal to 0 and figuring out when this derivative changes from negative to positive. All right. So, all right, I'm going to set it equal to 0, and I have negative 108 W to the negative second plus 4W. All right, so how do we solve for W? Well, if I subtract 4W, I get 4W here equals, now, negative 108, I'm going to rewrite that as over W squared. So if we do that, then we can realize that if we multiply by W squared, we get negative 4W cubed equals negative 108, and then this becomes, well, quite a bit easier to solve. So I divide by negative 4. W cubed equals negative 108 over negative 4. Obviously positive, but 108 divided by 4 is 27. Okay, so now I can cube root, and I can get that W equals 3, right? So that's great, W equals 3, but we have not answered the question or verified that this is in fact where a minimum occurs. So how would I figure out where the minimum occurs? Well, I would do a sign analysis on SA prime. So I put 3 on my number line, and we know that the derivative is 0 at W equals 3. And so now I have this factor, 108 W to the negative first plus 2, sorry, it would be negative 108. I'm sorry, I miswrote that. So we would have negative 108 W to the negative second plus 2W cubed. All right, so pick a number to the left of 3. Now, sometimes people are like, oh, 0, how about that? Well, 0 makes this thing undefined, right? I would have 0 to the negative second, so that's not okay. But let's pick, like, how about 1? So negative, I'm just going to write it over here, negative 108 times 1 to the negative second plus 2 times 1 cubed. All right, so negative 108 times 1 to the negative second, that would just be negative 108 plus 2. Of course, that's negative. All right, pick a number to the right, like 4. Negative 108 times 4 to the negative second plus 2 times 4 cubed, right? So negative 108 divided by 4 squared. So that'd be negative 108 over 16 plus 2 times 4 cubed. 4 times 4 times 4 is 64 times 2 is 128. So negative 108 over 16 plus 128, of course, that thing is positive. So our surface area derivative changes from negative to positive, indicating that there would, in fact, be a minimum at W equals 3. So to answer the question, what dimensions require the least amount of glass? So if W equals 3, then what is L? Well, remember, L is 2W, so 2 times 3, so L would be 6. And H, what is H? Well, remember, if I look back up here, H is equal to 18 over W squared. So h is 18 over 3 squared, or 18 over 9, so 2. So the dimensions would be 3 feet by 6 feet in width and length, and then height of 2 feet. So remember, this is in context. The volume is given in cubic feet, so you better make sure that the measurements are given in feet. All right, so that's slide number 2. So there's a lot going on there, all right, but the majority of this is just old stuff, right? So now all we're doing is setting up the problem, and that becomes the difficult part. All right, so that's slide number 2. All right, how about slide number 3? All right, it says an open top box is to be made by cutting congruent squares of side length x from the corners of a 20 by 25 inch sheet of tin and bending up the sides. How large should the squares be to make the box hold as much as possible? What is the resulting volume? All right, so I gave you a picture here, which is nice. All right, so this represents a rectangular sheet of tin. All right, so that means that this is 20 inches and this is 25 inches, right? All right, so now the question is if I cut x by x squares off of the corners of this, and then I fold along these dotted lines, now I'm going to have an open top box. All right. So as I fold those, okay, what are the dimensions of this new box? Okay, so let's look at this bottom edge. Okay, I took x off here and I took x off here. So now that means my remaining width is actually 25 minus 2x. Okay, same thing here. I started with 20 and I took x off here and x off here. So now my resulting length there is going to be 20 minus 2x. And then as I fold those sides up, x is going to be my height. So what would the volume of my open top box be? Well, it's going to be the length, 25 minus 2x, times the width, 20 minus 2x, times the height of just x. Now, this is a little different than the last problem, but remember, I started with length times width times height, and then I figured out what these were based upon my drawing. All right, so now this is what we want to find. Well, it says how large should the squares be to make the box hold as much as possible. So what does that mean? We're looking for the maximum volume, right? So now we have our equation here. So we want to find at what value of x v achieves its maximum. All right. So now what we want to do is we want to take the derivative of v and then find out where it changes from positive to negative, right? Remember, maximum would be positive derivative to negative derivative. Now, in order to do that, first thing I'm going to do is I'm actually going to multiply this thing out. So I'm going to multiply this out and then distribute an x. All right, so I have 25 times 20, okay? So 25 times 20 is 500. And then I'm going to distribute the x, so I get 500x. All right, then I have negative 2x times 20, so that'd be 40 minus 40x, but then I'm going to distribute the x to get an x squared. All right, and then I have a 25 times minus 2x, that would be a minus 50x, and then I'm going to distribute the x to get x squared. And then I have a minus 2x and a minus 2x, that'd be a plus 4x squared, but then I'm going to distribute the x, so 4x cubed. All right, so now I have this. I would probably simplify one more step. 500x minus 90x squared plus 4x cubed. All right, so that's my volume. That's what I want to find where the maximum occurs. All right, so now I'm going to take the derivative. So v prime equals, all right, derivative of 500x is 500 minus derivative of 90x squared, that would be minus 180x, and then plus derivative of 4x cubed, that would be plus 12x squared. All right, so now I want to set this thing equal to 0 and solve. All right, so now first thing that I'm going to do is I'm going to factor out a GCF. All right, so we want to take as much out as we can. So we can take out, well, let's see, 12, right? Is 500 divisible by 12? No. All right, but 500 is divisible by not 6, sorry. 500 is divisible by 4, right? So that would mean if we take a 4 out, I get 125 minus, now I have to take 4 out of 180, right? So 180 divided by 4 gives me 45 x, and then I took 4 out, so I have plus 3x squared. All right, so now I could divide by 4, which makes it irrelevant for the value of x. All right, and so now I have this. So now a lot of you guys probably want to rewrite it as 3x squared minus 45x plus 125. All right, so now we want to think about whether or not this thing is factorable, right? So I would have 3x and x. All right, and then I have 125. Well, 125 is 5 times 5 times 5, right? 25 times 5. So we have to think about whether or not this thing would work. So if I put a 25 here and I put a 5 here, right, and they're both minus, right? 25 times x would be minus 25, and then 3 times 5 is minus 15, right? So does that work? Well, no, right? But if I went the other way, that would not work either. You agree? And so then it looks like we would have to complete the square or something, right?